I'm building a NAS with all of this, a bunch of junk and spare parts I found in my storage closet. A couple old laptops, a Zima board, a Ugreen NAS, a TerraMaster NAS, an old Dell server, a pile of random servers and hard drives, and a few Raspberry Pis. That's my mission in this video, to build what I'm calling the FrankeNAS. Now, is this possible? Yes, with an open source magic technology called Ceph. It's software-defined storage, and it's crazy. It actually makes it to where all of these devices can connect together and act as one big, giant storage server, one NAS, the FrankeNAS. So in this video, we're gonna dive into what the heck Ceph is, and I'll show you how you can set this up yourself with pretty much whatever hardware you have. I mean, if I can do it with all this random stuff, you can do it too. So get your coffee ready. We're gonna make a FrankeNAS. Now, full disclosure, I already have Ceph running in my network right now. It's my new NAS, which I named Hagrid. It's very much a Harry Potter themed NAS, I love it. And Hagrid's not one server, he's 4 servers, all working together to act as one big giant storage server, or a storage cluster. And the magic behind that is Ceph. And let me tell you, I got features I've never had before. Things like tiered storage within the same folder. This folder's for HDD and this folder's for SSD. It's crazy. Now that's just one of the magic things it does, but why did I do this in the first place? Why use 4 servers instead of 1? Well, if you rewind maybe like 6 months ago, I had this one server, a Synology NAS, which was amazing. It was fast, and it did the one thing a bunch of external hard drives couldn't do. It allowed my team to collaborate together on one server. It was powerful. It had 16 bays of storage, but I ran out of it. We used it all. I mean, I make a lot of videos and they're 4K. So I had a problem. What do I do? Now, I could have just bought another Synology NAS, but I don't like that. You see, because when I buy another Synology NAS, I have to manage another server. They wouldn't combine, they would be 2 individual servers that I have to log into and manage separately. Now, maybe I'm being a bit dramatic. That tends to happen. Managing 2 servers, not a big deal. But what if we grow? What if I add another server and another server? What if I need more and more storage? What if I buy a different type of server, a different brand, manufacturer? It becomes kind of a management nightmare. And what I'm describing is not unique to me. A lot of companies go through this, and maybe individuals if you're insane like me. As you grow, one storage server isn't going to cut it. So now I have 4 servers in a Ceph cluster. And not only is this thing insanely smart and powerful, but I can expand it as much as I want. Sky's the limit. Actually, space and power are the limit. I don't have enough room here. But theoretically, I can expand it as much as I want, adding as much storage and servers as I need to. And it can be whatever I need it to be. Object storage? Yeah. File storage? Block storage? It can do everything. But how does this magic work? Let's talk about it. Now, Ceph is magic. There's no getting around that. Now, does it stand for anything? I don't think so. It's just Ceph. And what makes Ceph special is at first it's open source. We all like that, don't we? But it's also software defined, or software defined storage. What does that mean? Well, it means lots of things, but the biggest thing I want you to know is that software defined storage is hardware agnostic, meaning you can pretty much use any hardware you want within reason. So for example, our Ceph cluster that we're about to build. It's gonna be crazy. I'm gonna use a laptop, a few Raspberry Pis, an old Dell server. It doesn't matter, and this is amazing because traditionally when you buy storage, or you buy a NAS or a server or whatever, you're locked into the vendor. If you buy a Synology NAS, you gotta use the Synology NAS server with the Synology NAS software. Across the board, storage vendors, they lock you in, but it's time to break out. That was kinda lame, but I'm gonna go with it. Coffee break. But going with software-defined storage, like Ceph, this makes things a bit more flexible, scalable, and can be a bit cheaper, especially if you're just using stuff you found in your closet, like me. So how does Ceph make all this magic happen? Decentralization. This stuff is pretty crazy. But before we do that, I just want you to know, this whole storage thing isn't just for playing around. If you know storage, like how to manage it, administer it, not just in your house with your one Synology NAS, I'm talking like stuff like Ceph, or storage in the cloud, if you know how to do that, you can get a pretty cool job. Yeah, that's a job, a storage admin. And you can learn all those skills with our sponsor, IT Pro by ACI Learning. I logged into IT Pro right now and I'm like, I wonder if they have any storage courses. So I went and searched storage. And yeah, they've got quite a few, from AWS cloud storage to hybrid storage on-prem and in the cloud, even securing storage in Microsoft Azure. So if you're watching this video and you're like, man, this stuff is really fun. I wish I could do this all the time. You can! You might need a few certifications to learn more than you know now about storage, but it's possible. And if you're still pretty green, IT Pro has your back. Get your CompTIA A+ certification, Network Plus, Security Plus, learn Linux, get your CCNA. IT Pro has everything you need to get started in IT and advance your career. They've also got practice tests to prep you for any of those crazy exams and virtual labs, so you're not just learning theories, you're getting hands-on. So if you want to learn IT like me, check them out, link below. Thanks to IT Pro from ACI Learning for sponsoring this video. So let's talk about Ceph and decentralization. And by the way, the way it handles the servers and the hard drives is so weird. but it's wonderful. So here's an example of what I'm about to build, my Ceph cluster, so they call it a cluster. And notice each of these compute devices, my laptops, my Raspberry Pis, my Dell server, they have storage attached to them, whether it's an external hard drive, like an external USB hard drive, or an internal hard drive on my NASs, my NAS I, and my Dell server. So how does Ceph put all these things into one big pile of wonderful storage? Well, let's start with how we first install Ceph. We'll pick one computer, one server, to be our manager. Now for that, I want it to be something powerful, so I'll probably go with my Zima board right here. He is our manager. And by the way, the most complex part of this entire video will be explaining how Ceph works. Installing Ceph is actually pretty simple. Now as the manager, he's the boss. He calls the shots. He's got a few jobs, but his main job is just making sure the cluster works. He'll even get a nice GUI, the Ceph dashboard, that you can access and manage and do stuff. And at the same time, he'll also get the monitor role, which is super important in a Ceph cluster. You'll see why here in a second, but first, the manager's all lonely. He's got no one to manage. He needs some employees, some friends, some family. And that's where we add in the other servers. This island of misfit toys, the random stuff in my closet, let's bring him in. Now by the way, you can have a single server cluster for testing, but it's not nearly as much fun because it defeats the whole point of Ceph. So do something like this. Anyways, with just a few commands, I'm talking like a command per server you want to add, the manager will start to hire more employees. So he'll hire the Raspberry Pi, the laptop, and everyone else. Again, it's one command to make them part of the cluster, which I'll show you here in a bit. And then Ceph will just auto-magically assign roles to make sure that things are scalable and redundant. So he might make the Raspberry Pi 5 up here a backup manager or assistant to the regional manager, and also give him a monitor role. And he might assign another monitor role to the Ugreen NAS, so they can form what's called a quorum, which sounds a lot cooler than it is. No, that's pretty cool. You see, these three servers are like the mafia bosses, and they make sure everyone's staying in line. They make sure all the servers are healthy. They do a few more things, but that's the big stuff. I'll give them a little yellow underline on the monitor server, or a role, because they're pretty important. Now that's just getting Ceph on your servers. So at this point in your pile of stuff, or my pile of stuff, I do have Ceph installed. I've got a Ceph cluster. It's pretty easy to set up. But now what about storage? This was the first thing that made me go, what? When I heard about Ceph. See, normally when you deploy a NAS, you'll take all these hard drives and group them into what's called a RAID array, which essentially makes all the hard drives to function as one, which is pretty cool by itself. Amazing technology, you should learn it. But this is just within one single device. You see, we couldn't just simply do this with our scenario with our, a million servers and all the random hard drives. So here's what Ceph does, and it's so crazy. Watch this. Instead of making every hard drive come together as one, they treat every hard drive like its own thing. Every individual hard drive becomes its own unique component within cluster, called an OSD, an object storage daemon. And I want you to focus on the word daemon. No, it's not demon, it's not scary, unless you want it to be. I'm not sure what that means. Coffee break. You might remember that daemons are essentially just services in Linux. So for example, you might have the SSH service or the Docker service. Programs that run in the background. In each of these individual programs, you can start, stop, restart. But what's crazy is that each of the hard drives you have in your Ceph cluster are a service, a daemon that you can start, stop, and restart. They are their own thing. They're treated like their own thing. They're not just one big RAID cluster. They're an OSD. Now, do you see what's happening? Ceph is taking a storage cluster and breaking it up into parts, decentralizing it. So each hard drive is a part. Each service and role is a part that can be scaled out horizontally, grow as much as you want it to. So anyways, we're starting to see the story unfold. Back to OSDs. Each OSD or OSD service, daemon, is responsible for storing data on itself. And it's also doing things like data replication, recovery, rebalancing, and reporting relevant information to the monitors, the mafia bosses, the quorum. Now that's powerful and cool by itself. I didn't finish drawing out all the OSDs. I didn't forget about you guys. But what's even more powerful is how Ceph writes our data to the storage, to these OSDs. It is so crazy and fun. Let's break it down. And by the way, if you're like, okay, Chuck, enough theory, you can go ahead and jump to the tutorial. Timestamps below. No worries. But if you're a nerd like me, let's keep going. Ceph relies on a storage system called RADOS. I don't know if I'm saying that right. I'm just gonna roll with it. The Reliable Automatic Distributed Object Store. That's a mouthful. Oh my gosh. A fun fact, we've already talked about two of its main components. Mons, or monitors, and OSDs. RADOS, or RADOS, I don't know. It's the technology that's responsible for how things are written to the storage in your Ceph cluster. Watch this. Every file in Ceph is written as an object to the OSDs. And this is in contrast to a typical NAS, where files are written as blocks managed by the file system, which is fine. But what Ceph does with these objects is the secret sauce. You see, these objects can be distributed, replicated, and balanced across all OSDs in your cluster, providing high scalability and fault tolerance. And if you were to contrast that to a typical NAS with a RAID array, replication still will happen with your files, but it's confined to that one system. That one single point of failure, which I was not a big fan of, by the way. Very terrified that all my videos that I'm working on were on one server that could blow up. Okay, cool. Files are objects being distributed to the OSDs in our cluster. But it gets crazier than that. I'm telling you, Ceph is crazy, man. To help you see this craziness, let me show you how Rados will actually distribute these files to Ceph, or the OSDs in your Ceph cluster. Because it's not just like Rados to OSD. There's a few more things in between that make it go nuts. So let's get these objects out of here. We're not ready for you yet. The first thing we'll actually do is create a thing called a pool, a storage pool. And this is just a logical grouping of storage resources in a Ceph cluster. So for example, I might add a few SSDs to my cluster, brand new OSDs. And because SSDs are wicked fast, I want my video editing to occur on these SSDs. So I'll create a new storage pool and call it current projects, which is legit what I do now for my video editing projects. And that pool would only be OSDs that are SSDs. I would define these rules. And then I might create another pool for archives and put all the other slower spinning disk drives in that pool, which again, is legit what I do right now with my cluster. Now let's talk about that first pool real quick, current projects. In addition to saying, hey, I want it only written on SSDs, I can also say, hey, I want it replicated. It'll take each object it makes, triplicate it. Is that the word for that? I feel like it is. I'm gonna go with it. In the most fault-tolerant, highly available way. And same story for archives. I might opt to go with something called erasure coding, which is similar to RAID, just better. It's faster and more space efficient. And all you really gotta know is that it's similar to RAID 5 or 6, breaking data into chunks, adding parity chunks, and distributing those chunks everywhere. I've said chunks too many times and it's kind of making me feel sick. It's slower than just replicating, which is why I use erasure coding for my archives, but it's space efficient too. So cool, we have our pools, they have their purposes, and Rados just distributes stuff to our OSDs, right? No, you're getting ahead of yourself, buddy. Calm down. There's one more layer in between. I told you, Ceph is crazy. We have another construct in our Ceph storage called PGs, or placement groups. These are like your middle management, not because they're unnecessary, but because they're just in the middle and they're managing stuff. I'm sorry, I'm running out of analogies. Now this was the weirdest thing I encountered when trying to understand Ceph. Because at first I'm like, why do we need these? But I get it now. And the first thing you gotta know is that there are just a ton of placement groups. It's just crazy. So when we create our pool, and we define rules like, okay, make 3 replicas. And based on how many OSDs will be used for that pool, so let's say we have 3 OSDs. There's a calculation. Let me go find it. Here's the math problem you're gonna have to do. Take a sip of coffee. No, I'm just kidding. Actually, no, take a sip of coffee. But you probably won't have to worry about this. In most cases, Rados and Ceph will just take care of it for you. Just know that there is a calculation involved. And based on our situation, you might see 128 PSG, or I see a PSG. Anyone a PSG fan? PGs created, 128. Just for our current projects pool. If I were to add more OSDs, in fact, let's go ahead and do that. I'll add 2 more per server. The placement group number will go up. So with 9 OSDs, we might see it as 300 PGs created. Okay, you got the math, but what the heck are they doing? Why are they there? I get it, I was right there with you, but these things are essential into how data or objects can be efficiently and reliably distributed across your cluster. So here's how it works. Each PSG, so each of these 300, let me draw my visual representation of a PG. It's gonna be a guy holding a cup of coffee. He needs it. Each PG is assigned 3 OSDs. Let me give him a green hat because he's the green guy. So we'll say this OSD, and this OSD. One of these OSDs will be deemed the primary. So check this out. When I transfer my files, after we're done recording here, I'm about to do this, it's about to happen in real time, for real. When I transfer this video file that you're watching to my NAS, Rados is gonna take that file, convert it to an object, and then assign it to one of the 300 PGs. Mr. Green Guy just so happens to get it. Mr. Green Guy will look at his 3 OSDs and assign it to the primary OSD. The primary OSD, the daemon itself, will then go, okay, we've got a replication of 3 here. I'm gonna assign it to the rest of the guys on my team. So the object will be replicated to the other OSDs in this placement group. And you just saw how a file is saved to a Ceph cluster. Specifically mine, like this is legit how mine works. And just think about this, that green guy isn't used every time. I mean, out of the 300 PGs, they're all gonna be working, evenly distributing data across all the OSDs or hard drives in your cluster. It's kind of crazy, isn't it? It's a little beautiful. I like it. Coffee break for that because that's a lot, I know. Thank you for hanging with me. Now you know what's crazy? When I connect to my NAS to transfer a file, I'm not connecting to just one of my servers every single time when I transfer a file. No. You see, Ceph is way too distributed for that, too decentralized. When I'm transferring a file, or when I'm even reading a file, I'm connecting to the OSD itself. So when I transfer this video, it might live primarily on this server. But when I read another file, it might be on this server. And I'm making a connection with that server, with that server's IP address, which is so cool because think about this. I've got, see, 1, 2, 3, 4, like 4 video editors somewhere in this place, my studio. They're all accessing my NAS, but they're not all connecting to one server or one hard drive. Their traffic, their requests are being distributed across my 4 servers, from network to writes to reads. It's amazing. So anyways, to sum it up, storage is written to pools, which are then given to PGs, which are then given to OSDs who actually write the data to themselves. Thank you, Mr. Rados. Now you may have a lingering question. How does Rados and Ceph know how to place the data in the best way? Like how does it know like to go to this hard drive and this hard drive and this placement group? How does it know? Well, it crushes it. Sorry, that was it. I'm a dad of 6 daughters. You're gonna hear plenty of dad jokes in my videos. There's an algorithm called crush. That was what I was trying to tell you. I'm not gonna go too deep into this because this video is already crazy as it is. Just know this is an algorithm, which stands for, what does it stand for again? The controlled replication under scalable hashing. It sounds so crazy. Essentially, it's an algorithm that Ceph and Rados use to figure out where to put stuff and figure out where stuff is when we access it. And what's cool is that it's not like a centralized database because Ceph would never do anything centralized. That's a sin. It's decentralized in nature because it uses an algorithm to figure out where stuff goes and where to find it. It's hashing. If you want to dive deeper on that, I'll put a link below to the article of how Crush works. You'll need an extra cup of coffee, but it is really neat. Now, how Crush is structured. For example, like how it knows about each server or how many OSDs. It's defined in what's called the Crush map. And it's in this Crush map that will create rules. So for example, when I'd said, I only want current projects, that pool to be written to SSDs, I would create a Crush rule inside the Crush map. I know, it's getting to be a lot. That would define that. And that's just a simple version of what you can do with this. You can create rules to only write data to one certain rack and then write certain replicas to another rack in your data center to make sure you have high availability. You can spread it geographically. The limit's your imagination. It's crazy. But the main reason I wanted to mention Crush, and I was actually debating on whether or not to mention it because it's so heavy already. What's so cool about it is how it's always working for you to make sure that your data, your objects are being balanced and rebalanced. So for example, let's say I add a few more SSDs to my cluster. It's gonna intelligently use its algorithm to balance out your data. Same thing for if you lose a few SSDs, they're gone, they blow up. It'll intelligently reroute, rebalance your data, and it will do it in a way that minimizes data movement. So it's not gonna, throw an object way down the hall when there's a place for it right here. It's gonna be smart about it. And trust me, I know all this stuff's kind of scary, but it is very simple when we set up the Ceph cluster. A lot of this is just happening behind the scenes, but if you're a nerd like me, it does help to know what's actually happening, even though I'm not manually having to worry about this all the time. Now there's one more thing you wanna know about. I promise, it is the last thing though, but it's actually pretty stinking cool. It's the file system you're gonna use with Ceph when you set up file storage. And it's what I use right now for all my videos. It's called CephFS. So whereas you might have ZFS on Linux or NTFS on Windows, CephFS, 10 times fast, CephFS. Sorry, that's driving me nuts. It's specific to Ceph, as you might imagine. It takes advantage of all the decentralization goodness. Now, what do I mean by that? Well, normally files, they have what's called metadata. So not important things like the name of the file, how big the file is, file permissions, who owns it, who can access it, who can write to it. Where is that stinking file? With a traditional NAS and storage system, that metadata is stored alongside in the same location as the files themselves. But Ceph's like, nah, we're gonna decentralize the crap out of that. So when you create a CephFS file system on your Ceph cluster, a new role is created for your Ceph cluster, a role called MDS, or Metadata Server. Now this role, it's important, and you're gonna want some horsepower. So if you have a particular server that he's got some muscle, put it on him. So let's say Mr. Zima's already stressed out. Let's give the Terra Master the role of MDS. Let's also give it to Dell. He's got an old Xeon processor in him. He can do stuff. Now what this does is it decentralizes metadata. It also makes it highly available and produces the opportunity for parallel processing. So These metadata servers can be used both at the same time. And yes, there is a bit more to CephFS, but that's where we're gonna stop. We've already gone too far, I know, but how cool is Ceph? Like, the more I learn about it, the more I'm like, why haven't we always done this? This is so cool. And it makes me appreciate what I have going on in my server room right now. But enough talking about it, let's actually do it. Let's deploy a Ceph cluster on a random pile of junk and see how it does. Okay, first, what do you need for your Ceph cluster? Let's cover hardware first. For CPU, ARM or x86 is supported. And ARM would be like Raspberry Pi or your Mac, I don't know. And like all things in IT, the better the CPU, the better time you'll have. Many are supported though. As far as RAM, this is where you want to make sure you have at least 4 gigs, and again, more is better. Now, as far as actual storage, yeah, you're gonna want that. We're making a NAS. External hard drives or external SSDs. Those will work great. What will not work great is USB flash drives, which I don't have one on my desk right now. Why? I tried to make these work, it just doesn't work. Linux will see these as removable devices, and as of the latest version of Ceph, it's like, nah, we don't like removable devices. But if you get flash drives working, please let me know how that works. And of course, if you have internal storage, you can use that. Just don't use your OS disk. And finally, you'll need a network switch. Nothing too crazy, but this is the secret sauce in how Ceph works. It's how the cluster communicates, replicates, all the stuff it does over the network. Now for my lab, I'm doing a 1 gig switch, meaning each port is 1 gigabit per second. Now that's great for a lab, but in production, you'll want something a bit crazier. For example, my Ceph cluster right now, I've got 4 servers. Each of these servers has 4 10 gig NICs, all connected to my 10 gig MikroTik switch. And normally with Ceph, you'll devote 2 ports to front-end traffic, so when we access the cluster and transfer files. And then you'll devote 2 ports for back-end traffic, so think replication and storage balancing. But for our lab, 1 gig with 1 port is fine, and that will happen auto-magically. You don't have to worry about it. Now let's talk about software. What OS do you install on your host? For me, I'm going to be installing Ubuntu 22.04. That is the latest and greatest supported by the latest and greatest of Ceph, the Reef version. Now, of course, if you're watching this in the future and you're installing something beyond Reef, consult the documentation. I'm trying to cover it all, but I can't see the future. Now let me save you some headache real quick. If you're using Raspberry Pi for your cluster and you're using Reef 18.2.2, install Ubuntu 20.04 on your Raspberry Pi. If you try 22.04, it just doesn't work. For whatever reason, the Ceph Docker container will not run the ARM image. It'll try to do x86 and break itself. So I'm doing 22.04 on everything except for the Raspberry Pi's 20.04. And finally, you will need some coffee. It's just required. NetworkChuck.coffee, and let's get started. Now, the first thing you want to do is prep your host, and that will involve getting Ubuntu 22.04 on all of them. I have like, how many do I have, like 6 or 7? This took forever. And in addition to the OS, you want to make sure that you have SSH installed so you can access it remotely. That will look like installing sudo apt install open ssh-server. You'll also want to make sure that you have a static IP address. You'll have a better time if you do this. Now, how do you do that? Just jump into your net plan. We'll cd into etc net plan. ls that directory. You should see something like this YAML file right here. It might look a bit different, but just jump in there, sudo nano in that file, and do something similar to this for your network interface on that host. And the control X, Y, enter to save. And also, if you haven't done this already, make sure you update your repositories and upgrade your system with a sudo apt update and sudo apt upgrade -y. Now I'm warning you, the prep side of this is gonna take longer than setting up Ceph, but it won't take that long, don't worry. Next, we're gonna worry about the root user. Ceph by default loves the root user and he wants to use him. You don't have to, but it'll be a few extra steps, so we're gonna use the root user to make things simple. Now first, let's set a password for our root user. By default, your root user when you set up your system does not have a password. So we'll do sudo passwd root. Password set. Then we need to enable SSH login for the root user. And for that, we'll edit a file. Sudo nano, it'll be etc/ssh/sshd_config. Jump into that file and look for this bit of config right here. Permit root login. Right now it's hashtagged out, meaning it's not being used. Let's remove that hashtag and change the prohibit password from prohibit password to yes. Then control X, Y, enter to save, and then we'll restart our SSH service. Sudo systemctl, restart SSH. Rinse and repeat for all your hosts. That goes for every bit of config and setup we've done so far. Give me a second, I'm gonna set up on my host real quick. This is gonna take me a while. Root user done, now time for storage. We have to prep our storage to make sure that Ceph can see it and it likes it. And it's pretty picky. Don't worry, it's not too bad, just a few commands. So here in my Dell server, the first thing I wanna do is identify what storage I have in my system. The easiest way to do that is type in lsblk just like this. Boom, I've got lots of storage. What you wanna look for are things like this. SDB, SDC, SDD. These will be drives on your system. Notice I have SDA. I'm gonna ignore that guy because he has my OS installed on him. Leave him alone. Just make sure you're aware of what's happening there. Now, what I wanna do is prep these bad boys. I'm going to destroy them actually, wipe them clean. 2 easy commands. First, we'll use sgdisk to zap it. Sudo sgdisk. We'll use the switch -zap-all, and then we'll specify the disk. So we'll do /dev/SDB for me, whatever it is for you, and go. Put your password in. Now we're gonna use wipe fs. Sudo wipe, not wife, wipe fs --all, and then the drive, /dev/SDB, and done. Do that on every drive on every system. It's gonna take me a minute because I've got a lot of drives. I'll see you in a second. Okay, that took me a minute. Let's keep going. Just a few more things left in prep, I promise. Now we need to worry about software. We need to install a few things to make sure Ceph is happy. First is Docker. Yes, Ceph is going to run in containers. Lots of containers. By default, it uses Podman, but I prefer Docker. I like it better. So let's do that real quick. We're gonna install Docker on every host. Now to install Docker in the best way, refer to the documentation. Here I'm gonna grab, and this will be a link below by the way, I'm gonna grab their code to add their repositories, paste that here, rinse and repeat on every host. And yes, in case you're wondering, you can use Ansible to do all of this, including installing Ceph, but that's too much to cover for one video. Trying to keep things simple here, but really complicated for me. So you're welcome. And then with this one command right down here, we're going to install Docker. First host, yep, and the rest of the host. The next thing Ceph cares about is something called LVM2. Good news is that it's probably installed already by default on your system. Just to make sure, we'll do sudo apt install LVM2, and it should already be there. And then finally, we have to make sure things are good with time. Time synchronization is very important for a cluster because they have to make sure they're all looking at the same watch. We can verify that with one command. Time, date, CTL, status. What you're looking for here is the NTP service needs to be active and system clock synchronized, yes. If you see that, you're good to go. Now we're almost there. We're about to deploy Ceph, but we gotta do one more thing. We have to make sure the server that you want to be the manager, which I wanna make the manager my Dell server here. We gotta make sure his root certificate is on every other host or every other employee that he's going to hire so that he can log in without a password. So we'll do that with 2 commands, but first we're gonna get logged in as root. To do that, we'll type in su dash or space dash. Put your password in. This is for the password of the root user that you set earlier. Cool, I'm now root. Then I'll generate a certificate for my root user. Command will be ssh-key gen. Hit enter a few times, good to go. Now, with one command, we can send that key to the other host in our cluster. Well, they're not in the cluster yet. We're getting ready though. Host number 1, I'll send it to my Ugreen NAS. The command will be ssh-copy-id. Then we'll specify the username of our host. So it'll be root at the IP address of the other employee here. My Ugreen NAS, 23. That's it, right? Yes. Type in yes, put in the root password for the other system, and the key has been sent. Now to verify that works, let's try to log in from our manager to that new employee. We'll do ssh root at that new employee, 70.2.23, and we should have no prompt for a password. Boom, we're in. Awesome. If you do that, you know it works. I'm gonna exit to jump back into my manager and go ahead and rinse and repeat for every host in your cluster. I'm gonna do that right now. Whew, okay, I'm done. Everything's harder with 7 hosts, tell you what. Okay, now that our hosts are all prepped, we can deploy Ceph. And the best way I found to deploy Ceph is by using their tool called Ceph ADM. And that's our first task. We're going to install Ceph ADM on our manager host. Let's do it. First, we're going to set an environment variable, just like this. Ceph release equals 18.2.2. Now this is the latest release at the time of this video. If you get a later release, please change accordingly. Boom, environment, easy for me to say, environment variable set. Now time to pull down the code for Ceph ADM with this command. All commands will be below. Got it. If I type in ls, there it is, Ceph ADM. Now we gotta make this Ceph ADM executable, so we're gonna use chmod to do that. The command will be chmod +x and then Ceph ADM. Executable. Now we're gonna add the Ceph reef repo to our repos here using Ceph ADM. The command will be /Ceph ADM, add -repo, --release, and we'll say reef. Now again, if you're watching this video at a later time and we have a new release beyond reef, use that one. Ready, set, go. With the repo added, we can now finally install Ceph ADM. You thought I was gonna say Ceph? Nope. We're still installing Ceph ADM. One command, /Ceph ADM, install. Just like that, ready, set, go. Okay, that wasn't too bad, right? Now let's make sure it worked. We'll type in which ceph ADM. It's gonna look and see where that is. Cool, our command is living in user sbin. If you get this, you're good to go, you're solid. Now, can we install ceph now? Yes, we can, here we go. With one command, we will indeed install ceph. The command is ceph ADM bootstrap build. Love that movie. Then we'll use the option --mon-IP, and we'll specify our first monitor IP, which will be the IP address of this server you're on, your manager server. My IP address is 10.70.2.27, I think. Just gonna verify real quick, it's kind of important. Make sure you do it right. Yes, 27. Bootstrap is gonna make sure all the stuff we installed is indeed installed, and then install ceph. Let's do it. Ready, set, go. Woohoo! Now look what it's doing right away. I mean, first we see that it did make sure, hey, is time synced? Docker, is it here? And now it's pulling the ceph container image. Bootstrap is complete and ceph is installed. Now real quick, I wanna scroll up before we do anything else. You see this right here? Because our first ceph node is indeed our ceph manager, we've got a dashboard, a nice pretty GUI. What do you say we access it? Let's go here. And unless you have DNS set up, go ahead and access the IP address. So for me, that'll be 10.70.2.27. And I'm gonna go ahead and snag this password here. That was port 8443. Ah, there we go. Username is admin, password is that thing I just grabbed. And it's asking me to set a new password. Let's go ahead and do that. And it's gonna prompt us to log in once more with our new password. And we are in. Now you could do everything else from the GUI, expand your cluster and do all the fun stuff, but you know what? CLI is better, it's more fun. Let's get back there. Now we will visit here again to just see things, to get a visual for what we do in command line. But anyways, back to work. Now we gotta install one more thing. It's called ceph common, which will give us the ceph command. And we'll do that with ceph ADM. So ceph ADM install ceph-common. Ready, set, go. Now with ceph common installed, we can use a cool command to see how our cluster is doing. Ceph-s for status. Ready, set, go. Cool, so things are okay. I don't like this though. Got a health warning. That simply means it doesn't like the fact that we have one host in our cluster because we should have more in a cluster and we have no OSDs or anything going on. We haven't added anything, so let's change that. It's time to adopt some new employees. That's how you get new employees, right? Yes, you adopt them. But before we can adopt our employees, we gotta give them a passcode. We need to once again copy a certificate, a cert, to all of our future employees. It's like their badge to the building, their employee badge. And this is the cert that was generated by ceph. And it's a familiar command, ssh-copy-id, but we're gonna use a few extra switches. We'll say -f, -i, and specify a certain cert. We're gonna use certain cert. That's gonna be in /etc, /ceph, /ceph.pub. And then we'll specify the host. So root at 10.70.2. What's my first host? I always forget. 23. We'll send it over, done. And because it already has the root cert, you should not be prompted for a login. And go ahead and do that for every host in your cluster. This is way faster than anything else I've done so far. Okay, all our employees have their employee badges. Now, with one command, we can adopt a new employee and add the host to our cluster. Here's the command. And from here, things are kind of downhill. Like, it's super easy. The command will be ceph orch for orchestration, host add, and then we'll put the host name of our host. So the next one I'm gonna do is Ugreen. So I'll do ceph Ugreen. Now make sure that host name matches the host name of your system. Otherwise, it'll throw a fit. And then the IP address of your system. So 10.70.2.22? No, 23. Now that's pretty much all you need, but you can also add what's called a label. So we'll do --label, and I'm gonna give it the label of admin. And what this will do is make sure that Ugreen has the ability to administer the cluster. It gives him the keys to the kingdom here. Now we're gonna do it right now. Ready, set, go. Woohoo! Oh wait, hold on. Labels with an S. Ready, set, go. Okay, it added the host. And a lot of things are gonna be happening on the Ugreen host right now. When you see this, you know that it checked everything and made sure like, hey, the host name, it matches. It made sure the prerequisites are there. It has LVM2, it has Docker, and now it's gonna actually pull down those Docker images. All the ones it needs. And it's gonna start adding it to the crush map, which you may recall is just a map of what our cluster looks like. All the hosts, what the hosts are doing, what storage they have, or OSDs they have. So anyways, let's check the status. We'll do ceph-s. Okay, things are looking good. We got 2 daemons in our monitors here. And we have kind of a quorum. Ceph Dell, Ceph Ugreen. Ideally you want 3, if you have 3 or more hosts. Now let's go check on Ugreen. I'm gonna log in as root, su dash, and I'm gonna check the Docker containers. I'll do docker ps. And yeah, it looks like every container is running, just by default. You can see we have a monitor container, because it's gonna be a monitor. We got a node exporter, we got Ceph manager, because he's assistant to the regional manager, he's backup, and a few more that are essential to run Ceph. But it looks like things are good. That host has been added. Let's do one more command. We'll do ceph orch host ls, and this will list our host. Gives you a quick view on, hey, what's the status? Now, I hate that it's blank, but that's kind of a good thing. If it was down, it would say offline. Otherwise, we're good. And then we have our labels right here. We can see that they're both admins. Now, I told you it's all downhill from here. Adding a host is not too bad. I'm gonna add my other host as well. So I'll add Ceph HP, my little crappy HP laptop that I used in the NetworkChuck Academy Laptops and Mobile Devices course because I took it apart. All right, we'll do my Raspberry Pis. Okay, all my hosts are added. Let's do a ceph-s check on things real quick. Okay, things are looking good. Referring back to our Ceph architecture, you can see that right now I have 5 daemons as monitors. Looks like Ceph automatically is like, you know what? Let's just make them all monitors. Got quite the quorum here. And then we have our 2 managers, Ceph Dell as the primary, Ceph Ugreen as the backup. No OSDs yet. That's coming. Yep, I've got my 7 hosts in the cluster. So right now we're in a good spot. We've deployed Ceph, but we haven't done anything with storage yet. Every one of these hosts in my cluster have some sort of storage, whether it's internal or external USB drives. So how do we make them OSDs? Because remember, each individual hard drive will be an OSD or an object storage daemon. First, let's make sure that Ceph can see them. We did all that prep work, we made them look pretty. Let's make sure Ceph is happy. To check, we'll do ceph orch device ls. And a lot of stuff is going on here. Let me zoom out just a little bit. I've got a lot of hard drives across a lot of hosts. And just a few things you want to pay attention to. First, we have our individual hosts. So I've got Ceph Ugreen, Ceph Terra. We can see the hard drive types here. Ceph Zima has 2 SSDs. And then we have the status over here. Are they available to be added? Yes, 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 yes. You want to see that. That's a good sign. If you see no, there might be a reason. For example, it gives me a reason here. Insufficient space. And this is just my boot drive. So it's like, I don't care. But if you run into any issues where Ceph's like, we can't use that, make sure you did what we did in the beginning. SGDisk, wipe FS, make Ceph happy. Anyway, so we see all those available devices. Let's add them, and we can do that with one command. Oh, check this out. It's so fast. Let me just check my cluster status once more. Things are still good. Let's change that health warning to a health okay. That'll be one command, ceph orch apply OSD -- all - available - devices. Every device that had a yes and available in that column we saw is gonna get added right now. Ready, set, go. Kind of anticlimactic, it scheduled it, it's gonna start adding. Now, one command I wanna show you real quick because it's gonna be real time. Type in ceph OSD tree. This will list all the available OSDs. Right now there's 1. Let's check again. Oh, they're being added, check it out, it's happening. More and more coming in. Now they're all down status because right now, Ceph is actually reaching out to each of these employees in our cluster. Pull down a Docker container, run a daemon for each of these OSDs. And once that container is run and verified good, we'll see the up status happen soon. I hope. We'll give it a second. Just a little coffee break. Oh, a few are coming up. All right. Now you can see it's starting to organize them. So at first, like just had them in a big pile and it's like, oh, okay, hold on. These OSDs belong to this host. We're gonna organize them, make them look pretty. Oh, are they all up? Oh no, a few are still down in Ceph Dell. Come on, Dell, catch up. Almost there. Yes, they're all up. Now real quick, I wanna show you something. Let's do docker ps. You can see that I have quite a few Docker containers running. Specifically, so let me grep for OSD. All these containers are OSDs. If I look on my Pi host here, docker ps, there it is, an OSD container. Now let's do a ceph-s, check on our cluster real quick. Oh, we got a health okay. Oh, that's what I wanted to see. Health okay. Clean bill of health. We have 22 OSDs, or 22 individual hard drives. Now what's killer about this, just think about what we've done so far, is we have 7 hosts, and they're all just a mix match. Got a Dell server, a couple Raspberry Pis, an old laptop, and all the drives are different. A bunch of internal ones that are pretty big, terabytes. We got a few USB external hard drives that are like 500 gigs. We have a couple SSDs in the cluster too, that I think are each a different size. But try to do that with any other storage situation. It won't work. Ceph just makes it work. Now, ideally, I mean, if you're deploying a Ceph cluster, you want to have uniform hard drives. Same type, same size, but this is possible because of the way Ceph works. Anyways, you can see right now with my cluster, we have 38 terabytes of storage available. So cool. And notice by default, it did create a pool and one placement group for us. We're not gonna use that for anything. It's just created by default, which now with our OSDs in place, we can start doing stuff with storage. We can start having fun with this by creating our first file system. Yes, that's right. We're gonna use CEPH, can't even say it, CEPH. This is also remarkably easy. With one command, we're gonna deploy a file system. And actually, it's such an easy command. I'm gonna go ahead and type it in right now before I explain it. The command is simply CEPH volume create, and then we'll name the file system. We'll just call it CEPH. Now this one simple command will do a lot of things. First, it'll create two pools, one for metadata and one for data. It will also assign roles to our servers. The MDS role, metadata server, assigning one as active and one as standby by default. Enough talking, let's do it. Let's run our command. Ready, set, go. Oh, and I forgot to mention this will also auto-create placement groups for our pools as well. So let's do a ceph-s to check our status. Oh, we got some things going on. We got 3 pools already. Let's check it again. Oh, it's making our placement groups. Let's check it again. Yeah, things are happening. Let's give it some time. Give it some room to breathe. Little coffee break. And it looks like everything is good, which is such a good thing to see. I love this. Health is okay. We have 529 placement groups. Keeping in mind that a placement group, each one of these is assigned to 3 OSDs, at least by default, because by default, when it created these pools, they have a replica of 3. That means each object that is written to our file system, boop, triplicated, 3 of them. Those objects are assigned to a PG. The PG gives it to OSD1, the primary, and he replicates it to his brothers. Such a cool thing. Now let's go to the dashboard. Let's take a look at the GUI to see our hard work pay off. Let's just refresh our screen here. Hey, things are looking good. Look at this pretty dashboard. Couple of fun places to look at. Let's go to cluster, look at our host. Get all our hosts right here, looking good. Now we may get messages like this as it's kind of converging and replicating and talking to each other. We can look at our OSDs. We can see each individual hard drive and their usage. So far, nothing. Let's go to pools down here, another section. We have our pools with active PG status. So far, nothing going on. There's nothing on there. Let's change that. Let's actually use our file system. And this is where Ceph, I think, really shines. 2 things I want to show you real quick. First, for our Windows users, we're going to set up Ceph with an SMB share and test it out. Transfer some files, see how it works. I'll also show you for the Linux people how to mount Ceph using the Linux kernel. Ceph is baked into the Linux kernel, and doing it this way is blazingly fast. And actually, real quick, let's go ahead and mount our Ceph file system here on our Dell server. I'll show you what I mean. It'll be one command. Actually, first we'll make a directory. Make directory mkdir. We'll put that in mnt, and we'll call it Ceph. And we're gonna mount our Ceph file system to that directory. That's how Linux does things. And with this command here, we're gonna mount Ceph as a regular file system, giving it native kernel performance. Now I'm not gonna cover what all this means because this video is already too long as it is. And actually, hold on, I forgot one thing. We need to change the place where we're gonna mount it. We'll mount it to Ceph, that directory we just created. Ready, set, go. Ready, Ceph, go. So if we jump into that directory, cd mount Ceph, let's create a directory, say test. There it is. And let's add something to it real quick. We'll use this command to download a random cat picture. Done. Now let's check our cluster. We should have more objects there now. And yes, look here. We got some data going into our pools. Looks like it went to Ceph Ugreen, this OSD here. That's so neat, you can see that. Oh, I went to the other hard drive here. And I'll show you how to mount this on another Linux server, but real quick, we're gonna turn this mount into a SMB drive that we can access via Windows. So we had to do this first. Now let's install Samba. Sudo apt install Samba. I don't need sudo, I'm root, but it's okay. Yes, Samba is what we're gonna use to actually host SMB, the server message block, which Windows can access via a network share. Or Windows is using SMB to access the network share, whatever. Now let's do some basic permissions real quick. Let's make a new group. We'll do group add. We'll call it Ceph stuff. And I'm gonna add my NetworkChuck user, the one I created when I created this OS or installed the OS, to that group. So user mod dash lowercase a capital G Ceph stuff NetworkChuck. Cool, he's part of that group, or I'm part of that group. Now we're gonna change permissions on this directory here, this Ceph directory, and we'll do it like this. We'll first change ownership. We'll do chown or chown dash R, capital R for recursive, and we'll say the owner will be root, and the group will be Ceph stuff. Let's do that, cool. And then we'll change the permissions on that directory. We'll do chmod dash R for recursive, everything in that directory we wanna change. And we'll do 775 for Ceph. Cool. So basic permissions out of the way. Next, we'll set a SMB password for our NetworkChuck user. Command will be SMB passwd. We'll do -a and specify our user, NetworkChuck. Put in a password for him. Cool, password set. And now we have to define our share. And we can do that through the SMB config. So we'll do nano etsy samba smb.conf. Lots of default stuff here. We're just gonna create some space right here at the beginning and create our share. We'll do opening brackets and call it I love Ceph. And then just underneath that, we'll define parameters like the path. Where's it gonna live? It's in MNT Ceph. Is it browsable? Yeah, if I spell browsable right. Now it is. Read only? No. We can write to it. And I'll force a group permission on that to be my Ceph group. What did I name it? Ceph stuff? Yeah, I think so. Control X, Y, enter to save. That's all we need. And we'll do a systemctl restart SMB D to restart the service. That's all we have to do. Now let's add that share in Windows. I'm already here. Here in Windows on my Explorer, I'll right click and say add network location. Click on next, next, and then I'll do // and the name of my server. So 10.70.2.27, and we'll specify the share, which what did I name it? I love Ceph. Click on next, it should go try to find it. It found it, now it's like, hey, what's your password? Or username and password. We'll put it in, and we're good. Click on next, go ahead and open it. We have it mounted. There's our random cat picture. Oh. Now let's add some stuff to it. This is our Ceph cluster, my 7 devices with 22 hard drives. I'm about to transfer stuff to this. I'm so excited for this. I'm gonna grab some random videos here. Let's grab this and this and this. Just lots of stuff. 111 megabytes per second, not bad. And at this moment, let's go check the portal here. Let's go to our pools. Oh, we can see stuff is happening. Oh yeah, let's go to the dashboard. Got some IOPS coming in. Let's try and read the files. Let's just open up a video here. I mean, stinking fast. While it's playing, I'm going to see which OSD. Oh yeah, here it is. It's playing off Ceph Ugreen. You can see it right here. Let me try another one. Who's it gonna be now? Oh, it's still Ceph Ugreen, OSD2. So we got Windows with SMB. Let's talk more about Linux. And I wanna clarify something here real quick. With SMB, when we're transferring files, and then here's our SMB server, which is this guy. I'm always gonna be interacting and transferring files to that server. And then the server will be distributing the data to the OSDs, the individual ones where the objects are being mapped. And I wanted to highlight the fact that with SMB, you are tied down to that one connection. Whereas when you're doing Linux, with the native Ceph mounting, this will dynamically use and connect to the individual OSDs. Now you can mount Ceph in Windows. There's a way to do it. I think it's still in beta, which is why I'm not gonna show it here. Also, this video will be way too long. But anyways, let me show you Linux. So we've already mounted the Ceph here on our manager server. Let me show you how to do it on a remote machine as well. So let's do it on like this Raspberry Pi. Now first we have to make sure that Ceph common is installed. So we'll do a sudo apt install ceph-common because it will use Ceph to mount the drive or the file system. And also in order to mount the file system, we'll need credentials. Specifically, credentials found in etc Ceph. Pretty much everything right here needs to be transferred over to our server. And we'll just do that with SCP. So SCP, we'll copy this entire directory to our remote server. We'll make sure we copy everything just so. Cool, it's all copied. Let's just make sure it's there. Cool, it's all there. So now, same story as before. We'll make a new directory. Let's call it MNT Ceph. And then we'll use that same mount command from earlier. Just paste that in right here. And it should be mounted. If we go cd mnt Ceph, there it is. There's all the files. Now there's so much more I could show you with Ceph. Actually, you know, let me show you my current cluster right now. I've got 9 million objects, a bunch of PGs. You can see if I look at my OSDs, all the data is pretty much distributed evenly, except for the SSDs, which is something I haven't showed yet. You can do storage tiering. You can do block storage. You can integrate Ceph with Proxmox, which I do have that integrated right now. Object storage. So if I go to block and images, these are all hard drives on my Proxmox. You can create images, create hard drives, block storage here as well. You can create an extra drive and mount it in Windows like an internal drive. It's so cool. If you want to see more, let me know, comment below. Maybe I should make a part 2 or maybe do some bonus videos on the Academy. I'm down for it. Anyways, that's all I got. I'll catch you guys next time.